Hello, we are discussing about GATE 2014 and this question is related to analog circuits. In the voltage regulator circuit shown in the figure, the op amp is ideal. The BJT has VB is equal to 0.7 volts and beta 100 and the zener diode voltage is 4.7 volts. For a regulated output of 9 volts, the required value of R in ohms. So the required value of, look at the diagram, we are going to calculate R value over here. This is how much is going to be R value if V0 has to be 9 volts. What was given is this transistor is going to be having VBE of 0.7 volts and beta value of 100 and this zener diode is given with 4.7 volts. Okay, it is very easy to calculate. We are going to calculate R value. If you want to calculate R value, you must know about the voltage drop across this resistor and you must know the current flowing through this resistor. Assume that one voltage drop across this one is nothing but V and current flowing through this one, okay, is going to be I. By that time, can I write like this? V by I is nothing but the value of R or not? Okay, if you know these two things, at that time you can easily calculate R value. Okay, so what is the value of V? And given that one op amp is ideal op amp is nothing but whose AV voltage gain is going to be infinite. So whenever AV voltage gain is going to be infinite, that can be written as V0 divided by VID for operational amplifiers. That is nothing but input difference voltage. So from this one we can write it as VID is equal to V0 by infinite, which is nothing but something by infinite is 0. So VID can be written as V plus voltage at non-inverting terminal minus V minus voltage at inverting terminal, which is 0. So this is nothing but V plus is equal to V minus. This is going to be called as virtual short concept. Virtual short. It is very important concept. This is only exists whenever the op amp is ideal and that too AV is equal to infinite. Whenever voltage gain is infinite, we can say that one there is a virtual short exists in the operational amplifier input terminals. That is, both the input terminals are at the same voltage if AV is equal to infinite. So if one of the terminal voltage is going to be at some voltage, at that time the other terminal will be having at the same voltage. So look at this one. Okay, what is the voltage across inverting terminal? That we are going to find out. That is, voltage at inverting terminal is this one. This is connected with a zener diode and zener diode is going to be given with 12 volts. 12 volts is greater than the zener breakdown voltage, so that this will be in zener breakdown region. Zener breakdown region. Whenever it is in zener breakdown region, it maintains a constant voltage as Vz. Irrespective of applied voltage, it maintains constant voltage as zener breakdown voltage. That is nothing but it maintains 4.7 volts. So voltage across non-inverting terminal is 4.7 volts. And because of virtual short, as AV is equal to infinite, inverting terminal is also at 4.7 volts. Inverting terminal is also at 4.7 volts is nothing but at this point also you will get 4.7. That is nothing but voltage across this one is nothing but 4.7 volts. So we know V is equal to 4.7 volts divided by what is the value of I. Okay, so can we say that when the current flowing through 1 kilo ohm is also flowing through R? That is, current flowing through 1 kilo ohm and current flowing through R are going to be same. Otherwise this I is going to be looks like it is dividing into this one two sides, two branches. It is going into inverting terminal as well as it is going into the R. Even though it looks like the current flowing through 1 kilo ohm resistor uh, is dividing into current flowing through inverting terminal and current flowing through the actual R what we require. But current flowing through internal terminals I minus is equal to 0 for ideal operational amplifier. Okay, for ideal operational amplifiers what we know is nothing but Ri is equal to infinite for ideal operational amplifier. So that because of that one, we can think that one current flowing through inverting terminal and non-inverting terminal are going to be 0. Okay, since the infinite resistance is nothing but Ri. Ri is going to be infinite. Ri is infinite is nothing but input side is acting as open circuit, so that no currents are flown in the input side. That's why I plus and I minus, that is current flowing through non-inverting and inverting terminals, are 0. So that entire current, whatever the current flowing through 1 kilo ohm, that also flows through this R. So I am going with this is the I. Okay, so this I can be calculated as voltage drop across this 1 kilo ohm resistor divided by 1 kilo ohm. So what is the voltage drop across this resistor? Top side of this resistor is connected with 9 and bottom side is connected with 4.7. This is the voltage difference divided by 1 kilo ohm, which is nothing but 4.3 divided by 1 kilo ohm, which is 4.3 milliamperes. So this is the same current which is also flowing through R, so that we can go in this way, 4.3 milliamperes. So R value is going to be looks like 1.09 kilo ohms. Otherwise, in terms of ohms, we can write it as 1090. So the right answer for this question is 1090 ohms. Thank you.